Einstein's theory of relativity, explained simply. The theory of relativity was developed by Albert Einstein in the early 20th century. It explains how time, space, and motion are connected and how they behave differently depending on speed and gravity. The theory consists of two main parts: special relativity and general relativity. 1. Special relativity, when things move fast. This theory focuses on objects moving at constant speeds, especially those approaching the speed of light, 299,792,458 meters per second. It is based on two main principles. 1. The laws of physics are the same for everyone, no matter how fast they are moving, as long as they are not accelerating. 2. The speed of light is always the same, no matter how fast the observer or the source of light is moving. Put simply, the speed of light is always constant. Let's look at an example. All right. Imagine you are in a car, and your friend stands on the sidewalk. If you throw a ball forward inside the car, you see it moving at a certain speed. But to your friend outside, the ball is moving even faster because it's going forward with both the speed of your throw and the speed of the car. Now, here's the cool part: if you were shining a flashlight instead of throwing a ball, you'd think the light should also move faster for your friend outside. But nope. Light always moves at the same speed, no matter what. Because of this, time and space behave in really strange ways. If you go super fast, close to the speed of light, time slows down for you compared to people who are not moving as fast. Distances also shrink. This is called the theory of relativity, because time and space are relative to how fast you're moving. Isn't that mind-blowing? Let us look at some key effects of special relativity. 1. Time dilation means that time slows down at high speeds. If you travel really fast, close to the speed of light, time slows down for you compared to someone on Earth. For example, astronauts on the International Space Station age a tiny bit slower than people on Earth because they are moving very fast. 2. Length contraction. Objects moving at high speed shrink in length. 3. Mass increase. As an object moves faster, its mass increases, making it harder to accelerate. One of the most famous equations from this theory is E equals mc squared, which shows that energy and mass are interchangeable. This equation is the foundation of nuclear energy and atomic bombs. Imagine you have a tiny key, but inside it, there's enough power to launch a rocket. Sounds like magic, right? That's what Einstein's equation tells us. What does E equals mc squared mean? E, energy, this is power, like the energy that makes lights turn on. Ma, mass, this is how much stuff something is made of, like how heavy your key is. C squared, speed of light squared, a light is the fastest thing ever. When you multiply it by itself, you get a huge number. This means even tiny things have lots of hidden energy. For example, the sun takes tiny bits of matter and turns them into huge amounts of light and heat energy. That's why it shines so bright. 2. General relativity, the science of gravity. Einstein's general theory of relativity expands on special relativity by explaining how gravity affects space and time. Instead of thinking of gravity as a force, like Newton did, Einstein proposed that mass bends space and time, creating a gravitational field. To visualize this, notice how a heavy ball placed on a trampoline creates a dip. Let us look at some key effects of general relativity. 1. Gravitational time dilation. Gravity slows time. The stronger the gravity, the slower time moves. Example, time runs slightly faster on a mountain than at sea level because Earth's gravity is weaker higher up. 2. Gravitational lensing. Gravity bends light. Light bends when it passes a strong gravitational field, like around the sun. Example, astronomers use this effect to see faraway galaxies hidden behind stars. Now that you have a broad understanding of topic, let's look at some real-world examples of relativity. 1. GPS satellites need Einstein's equations. GPS satellites orbit Earth far from its gravity, so their clocks tick faster than clocks on Earth. Without relativity corrections, GPS would be inaccurate. 2. Black holes and time travel. Near a black hole, time slows down dramatically. In movies like Interstellar, astronauts near a black hole age slower than those far away. In the movie, the planet that the main character travels a black hole called Gargantua. The black hole's immense mass causes time to pass more slowly on the planet. For example, for every hour on the planet, 7 years pass on Earth. 3. Astronauts age slower in space. Astronaut Scott Kelly spent a year in space and returned slightly younger than his twin brother on Earth. Now, let us quickly recap what we learned. The theory of relativity was developed by Albert Einstein in the early 20th century. It explains how time, space, and motion are connected and how they behave differently depending on speed and gravity. The theory consists of two main parts, special relativity and general relativity. Special relativity is based on two main principles. 1. The laws of physics are the same for everyone, no matter how fast they are moving, as long as they are not accelerating. 2. The speed of light is always the same, no matter how fast the observer or the source of light is moving. The key effects of special relativity are time dilation, length contraction, and mass increase. On the other hand, in general relativity, Einstein proposed that mass bends space and time, creating a gravitational field. The key effects of general relativity are gravitational lensing, gravitational time dilation, black holes, and gravitational waves. That is it. The theory of relativity is simplified for you. If you found this video helpful, smash that like button, subscribe and click the bell icon so you never miss a video, and share this with someone who struggles to understand boring old textbooks. We hope you enjoyed watching this video as much as we did making it. Thank you for watching. Like and subscribe.